All right. The first thing that came up was financial services, and it does sound like they're going. Oops, here's Brianna must have had difficulties. She went out and now she's coming back. So let me get her here, or else she's here twice. I don't know. Was it 21 students before or 20? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, someone else has come in. Oh, I see. Brown is in here twice. Okay, that's fine. Okay, she's going to get double her money's worth today. Okay, the first question dealt with financial aid, and as far as I know, it sounds like what you just told me, Janae, that they were going to send it yesterday, was it? Okay, so I think someone has his microphone on and doesn't realize it. Okay, thank you. It sounded like Janae's issue was the financial services, and they told her that it was going to be posted to direct deposit as of yesterday, Monday, or this coming Monday?
Yesterday, the 28th.
Okay. And have you been able to confirm whether it got there or not?
Nope, it has not.
It has not. Okay. Okay. So some people. Okay. Okay. Understand this. Banks do weird things sometimes, and I'm not saying your bank does this, but I have heard this. Okay. Here's what I know that some banks do, and I'm not saying yours does. They may get in a deposit and let it sit there a couple. Yes. Did someone have something?
When they're going to do the deposit, when you sign into my lawson, it says it's going to take 1 to 2 business days to receive it, and you have direct deposit.
Okay. Did everybody understand that? It may take 1 to 2 business days for it to get. Yeah.
And if you didn't update it by the 25th, then they're mailing it to you.
Okay. All right. Did everyone understand that? Okay. I'm sorry it's taking so long, but this is growing pains through this new program. Okay. Now the second issue is one more concerning, because I talked with Dee last night about it, and then Janae sounds like she's having the same issues. Have any of you been able to successfully open the test? No. And you have tried, but you can't get. Okay. Now, let me go to mine and just see what that's like. Okay. I'm going to go to Math 112. Get out of this one. That's what I was working on before. I lost track of time. Okay, let's go up to Math 112. And let's see, maybe it didn't post well from my end. I usually don't pull it up again just to see, because most of the time it posts well. Okay, there's today's class, but y'all can't see it because it's not on Zoom yet. Okay, now, I can't recall now whether I was able to post it under weekly assignments. Some of these weekly assignments will post and some will not. And let me see if it posted here. Under message. Okay. Okay. I know I tried to post it under week 6 test 1, but I don't think it would let me do that. And whoever set up these templates, yeah, they wouldn't let me do it because they didn't put a plus sign here for me to do that. So it's not there. Okay. So let me close out that and close out this and close out. I love this Blackboard. It's just so convenient. Yuck. Okay, here it is under messages. So I'm going to get Zoom started so we can share the screen here. And this is Google content here. Okay, everything is in the way here. This is so aggravating, this system. Okay, let me get this toolbar, taskbar out of the way, and let me get Janae's name out of the way. No, that's still in the way. Let's go back down here. Now I can. Okay, can you see my screen? My Math 112 pre-calculus. And there's the messages. Everybody knows about that message icon, right? So that's where you click, and there it says attached to the first test. And a sheet of graph paper. Unfortunately, the graph paper had light blue lines, blah, blah, blah. I also tried to post the test under test 1 in week 6. It wouldn't let me do it. So let me go here. I click on my name, and it underlines. And when I do that, the test comes up over here on the side. Okay, so let me move y'all out of the way again. Let's look first at the test. Okay, I'm going to click on the 3 dots and download the original file. It takes a few minutes to download, and when it finishes downloading, now it says Q1. It used to be Quiz 1. And now it's trying to open, and it's opening under Word, and I thought it was under... Okay. Now, can you see my screen? And I'm guessing that's not what it looks like on your screen. Is that right?
What exactly are we looking at, Mr. Fowler?
That's the first test. It says Quiz 1, but it's actually the first test.
Like, do you have it pulled up? Because I don't see anything.
Oh, wait. Okay. For some reason, I'm sorry. I started sharing, and it said it was sharing, and then it quit sharing. Okay. Can you see that now?
Yeah, we can see it.
Okay. Is that not what you see when you pull up your test? Or, yeah, test 1. It's named Quiz 1, but that's really going to be test 1. Do y'all see that, or it doesn't look like that? Okay, now I just went through those steps. You want me to go back through them? Okay. Now, here's the problem. I think someone else may have just tried to enter the class. Let me see if anyone's waiting. Yep, there's Ladarius. Let me get Ladarius in here. There we go. Ladarius is here. Okay. I ran into a problem similar to this in a calculus class this past summer. That when I put the test out there, students said they couldn't read it. Is that the case with you too? Your test or quiz doesn't look like this one.
I got it pulled up, but some of the equations are like cut off.
Okay. I think, would it be especially number 3? Is number 3 one of them that's cut off?
Yeah.
Okay. Let me guess again. Oh, wait. Here's somebody else, I think, in the class. Yes, Weston's coming in. Let me get Weston here. All right. Turning out to be a great attending class today. Super. Okay. So here's what I'm going to have to do. This is what I had to do last summer, too. What I think is the problem, let me see. Would your number 6 not, did it cut off some?
It's 3, 4, 6,
Yeah, I was just going to say that. 7 is okay, though? Okay. 8, that makes sense, too. 9 came in okay? No, it didn't. Okay. All right. Here's what happened. You see all of those that you just said, 3, 6, I thought 7 too, 8, and 9. I went to what they call the graphing editor or whatever they call it. In Word, it's an awful package. It's terrible. It's gross. It's miserable to deal with. Okay, and evidently your versions of Word will not pick up, and Word does this. Microsoft products do this worse than just about anybody else's because they have a monopoly on the market. Anytime they upgrade and change something, they make it so none of the previous versions will do that properly, so you have to buy the new package. And the other packages, WordPerfect, that I used to use all the time, they always made them compatible, okay, until they did a really major change, and then they called it something different, just so people would know if you want to go this way, you're going to have to buy this. But Word is notorious for doing this. So what I'm going to do, and it's going to be this evening before I have a chance to do it, I'm going to take a scan of this, Adobe scan of this test, and put it out there under same place, under messages, but I'll say here's another copy of it for those people who could not read the questions on the other one. Sorry about this. I hadn't had any problems since this summer, but evidently I really dislike Microsoft products. I know they dominate the market, but in dominating, they do get away with all sorts of mess that nobody should let them get away with. But anyway, I'll do that, but it'll be late this evening because I'm in class from now until 5:45 today, with only 2 15-minute breaks and 1 30-minute lunch break. And somebody, I think, I'm sorry, I can't hear you. Yeah, I just saw that someone had come in, and Weston didn't get in either. I don't know why. And Tamia is trying to get in. Yes. Okay, say that again. No, 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 no. The test, we haven't even finished 1.6. We're going to finish 1.6 today, and technically it'll be due a week from today, but if you need more time, you certainly can have it. Okay? So don't sweat the thing. Now, did Blackboard put a due date on it? If they did, say again? Okay. Uh, okay, I can't hear you, sorry. Okay. Okay. Well, I'll check and make sure they don't have a due date on it that's stupid, because Blackboard just throws them in there when I don't notice it, and I'll try to check and make sure that there is, if there is a due date, it's way out in the future. Now here's when it really is due. Okay, I'd like you to shoot for getting it done in a week if you can. If you need more time, you certainly can have it. But I want you to have it done before we get ready for the next test, which will be at the end of 1.9. And hopefully 1.7, 8, and 9 will go much faster than 4, 5, and 6 did. Hopefully we'll get all these other administrative and other things out of the way, and we can focus more on this. So I will try to do that this evening to get the Adobe scan and put that out there on Blackboard messages. And then for those who can read this one, you can go on and be working. The others, it'll be this evening before it gets there. But don't sweat it. You have plenty of time. Okay? So, any other questions on the quiz? It's a test. It's really a test. Okay, I'm going to move these people out of the way. And I think somebody just came up. Did someone just send the chat? I've got so many things open, it's really hard for me to get chats done. If you have something that you can say out loud, say it, you know. I think it'll benefit everybody.
Hello, Mr. Fowler.
Yes.
This is Janae.
Yes.
Yeah, my internet went out for like 2 minutes. Did you say we had to show our work or no? I'm sorry about that.
Okay. Yeah, that's another really good question. And here's my answer to it. This would be the same if we were in class or whatever. I try to give as much partial credit as I can. So if I can see your work and see you're heading in the right direction, even though you got a wrong answer, I can give you more partial credit for it. But if you're really confident you got the right answer and you just want to write the answer down, that's up to you, okay? I'll grade what's on the paper, but if you do show your work and you miss something, I'll try to give more partial credit. Okay? Probably not. Okay, glad to. All right. So let me get out of this. I hope everyone heard that. It is being recorded, so let me go back to screen share, and this time we will do 1.6. I get too many things open and it seems like it just bogs down the system here. Okay, it says screen share has stopped, but then it's saying screen share is happening. So Zoom, I think I have.
Mr. Fowler,
Yes.
one more thing before we get started. Do we need to submit a rough draft to you about our term paper? I couldn't remember.
Not necessary. I want to only grade your paper. Okay, I don't want to grade it twice. I've got. Okay, I think somebody has a microphone on. Don't realize it. Okay. Okay. Someone's microphone. Okay. No, I can't tell. Okay. About the term paper, give me your finished product. Okay. You can run it by other people. You can have people check it for you, whatever. Don't have them write it for you. Have them check it for you. But no, I only want the final product. I will grade that and give you your score. Sorry about that. I have 7 classes right now. I may be adding 2 more in the second mini term. I do not have time to grade, and some of these yours is the biggest class, but I have 2 other classes, 20 or more students, or close to 20 or more students, and then several other classes. So I just, I can't grade all the papers twice. So no. All right, glad to. All right, any other questions before we get started on pre-calculus algebra today? All right. Yes. Okay, yes. You can email. Okay, this will be the test, the paper, whatever. You can always attach it to an email and send it to me. You can attach it to a Blackboard message and send it to me. On the test, there's actually a place in week 6 that you can send it that way if you prefer. I've had students who prefer doing that, so I've started doing it. I couldn't put it out there, but I think you can attach things there. I don't know. Whoever set up this template, they forgot to put the function there that allows me to attach something, but I think you can attach. So any way you can get it to me, get it to me. I actually had a person either last spring, I think it was last spring, who preferred to mail me their papers. Fine, I'll take it. So if you need my mailing address, I will give you my mailing address. Okay. Any other questions? Good questions, by the way. All right. Then we're picking up from the current slide here, and for some reason it just advanced. We're in Chapter 1, Functions in the Graph. 1.6, a library of parent functions. We're on page 64. The subtitle near the middle of the page that says parent functions, exactly what you got on the screen. And we've been over these. This is sort of a summary of these parent functions. So you can recognize them, use them, whatever. Okay. The 8 graphs shown below represent the most commonly used functions in algebra. This is the constant function. Okay. F of x is equal to a constant c. No matter what x you use, x equals 0, you're that constant c. X equal 1, the constant c. X equal 2, same constant c. X equal 3, same constant c. X equal negative 0.4, same constant c. It doesn't matter where you go. X equal pi, same constant c. You know, anything. X equal 4,575,814 and 3/4 would be c. Okay, so that's the constant function. Okay, notice it doesn't have the slope is 0 and it has a y-intercept at c. Everything goes through c. Okay, the domain of this function is all real numbers. The range of this function is only that value c. That's the only allowed y value that you have. That's the range. Okay. It's a linear function. It's just that the slope is 0. Now, the second of these is also a linear function, but this is called the identity function. That's f of x is equal to x. So give me an x, 1. I'll give you the f of x, 1. Give me x, 2. F of x is 2. X equals 0. F of x is 0. X equal minus 1. F of x is minus 1. X equal minus 2. F of x is minus 2. That's the identity function. The y value is identical to the x value. And that's the slope of, that's a linear function, slope 1, y-intercept 0. Okay, that's the identity function. Now, the absolute value function, if you ignore this side, it looks just like the identity function on the right. Okay, absolute value of x. Now it doesn't have to be absolute value of x, it could be absolute value of anything else, but that is the positive values that you get, whatever x you put in here. If you put in something that produces a negative in here, that flips it and makes it positive. So you take this and flip it up here and make it positive, and that's exactly what you got here. Absolute value function is always going to be a V-shaped function. Sometimes it'll be very wide V, sometimes a very narrow V. It won't always be at the origin. It could be anywhere else. It could be turned upside down V, okay? Absolute value will always look like that, okay? But this is the parent function. This one goes through the origin, is identity function on the right, exactly the opposite of the identity function on the left. Fourth one of these is the square root function, and I don't know if this is bothering you, but okay. Here's the square root function. Notice its domain is only non-negative real numbers, 0 and positive. Everything 0 to positive infinity, including 0. Okay. You can't take the square root of a negative number. And because this square root symbol indicates the principal square root or positive square root, the y is also, the range is also from 0 to positive infinity. You don't have any negative y's down here either. Okay? Square root function starts off going up pretty steeply, but then smooths off, levels off, and gets more and more close to level, but it never gets level. It's always slightly increasing. Okay, that's the square root function. Okay, now remember this shape, okay, because what we're going to go to next is the squaring function. They call this a quadratic function. This is the parent function for all quadratic functions. I call this the squaring function. The f of x equal x squared, the y-intercept and x-intercept are both 0, 0. It's an even function because it's the same thing on either side of the y-axis, decreasing over here, increasing over here. That's the squaring function or the quadratic function, the parent function for quadratics. Now, the reason I said remember the shape back here, this is exactly half of a sleeping parabola, okay? This is a parabola. Turn it over on its side, put it to sleep, and then take the upper half, and that gives you the square root function. This is a squaring function, that's the square root function. Notice how similar they are. It's just that you flipped it on its side and only taken half of it. Because otherwise, it wouldn't be a function if you had the other half of that parabola down here, because a vertical line test would fail. Okay? This is the cubing function. They call it the cubic function. That's okay. It's a parent function for all cubic functions. It's increasing everywhere. It goes through the origin. That's the x and y intercepts. Increases over here. Even here where it looks sort of flat, always slightly increasing, doing that. Here's a reciprocal function. Not defined at x equals 0. Okay? Neither is y ever 0, because you can never have the y equals 0 if your numerator here is not 0. And it's not in this case. It's 1. So therefore, this has all real numbers for the domain except x equals 0, all real numbers for the range except y equals 0. Okay? And it's always decreasing here, going quite low, starting quite high here, and decreasing rapidly and then more slowly. That is a decreasing, a reciprocal function. And then the greatest integer function is just one sample of a step function, okay? Not the only step function you have out there, but the one they like to focus on. And we talked about that pretty much too. It says familiarity with the basic characteristics of these simple graphs will help you analyze the shapes of more complicated graphs. In particular, graphs obtained from these graphs by, get this, rigid and non-rigid transformations. We have not seen those words before. Guess what? That's what 1.7 is. Okay? That's where we're heading next. We're going to be translating and transforming these functions. Okay? Now, I think that's the last slide. Yes, it is. There is a summary at the bottom of page 64. There are vocabulary questions at the top of page 65. Let's do those first. In exercises 1.9, 1 through 9, okay, this is the 1.6 exercises, top of page 65, vocabulary. In exercises 1 through 9, write the most specific name of the function. Okay? Now, I'm guessing not all of you can look at your book while we're doing this, so I'm going to go to the whiteboard and write these down, and you tell me the names. Okay? Now, everything's in the way here. I'm going to have to do some moving around. Get Kanisha out of the way. Get this taskbar out of the way. And get my whiteboard moved as far to the left so that those other places aren't bothering it. And get them as far up as I can so those places aren't bothering it. I think we got it there. Okay, so here's the first of these. If I can get my pen to show up. F of x is equal to this funny looking setup here. Now my writing kind of stinks, but if you can make that out, what's the most specific name for that function?
Is it greatest integer?
Greatest integer function. You got it. Bing, bing, bing. Okay, number 2. F of x is equal to x. Now you could say several names for that one, but give me the most specific name for it. The identity function, perfect. Number 3, f of x is equal to 1 over x. Reciprocal function, perfect. Number 4, f of x is equal to x squared. Say again? That's not a root. The squaring function, or the book calls it the parent function for the quadratic functions. Either one will do. Okay? Number 5, f of x is equal to, and that's where somebody was looking ahead, I think. What was that one? Well, the square root function. Yeah, the square root function. Perfect. Number 6, f of, yes. Okay, your microphone's off, so I can't hear you.
I'm sorry. If the f of x equals x squared, what was that called?
Okay, the book calls it the quadratic function, the parent function for all quadratic functions. I usually call it the squaring function because that's exactly what it's doing. It's taking whatever's inside and squaring it. Okay, but you can call them either one, squaring function or quadratic function. Did that answer? Okay, good. All right. Number 6, f of x is equal to c. Constant function, perfect. Number 7, f of x is equal to, and this time they just have a single bar around each side of the x. What's that? Absolute value function, perfect. Number 8, f of x is equal to x with a superscript of 3. Cubic functions or cubing function, either one will do there. And f of x, this is number 9, is equal to, they didn't have a picture of this earlier, so you'll have to remember this one from the past, but you should. What would be the most generic, specific name for that one? Okay, that is, okay, you name the type of function it is, the type of form it is. It's the slope-intercept form of a linear function. Okay, a linear function. Okay, and that is the slope-intercept form of that. Now, number 10 is a fill in the blank. The constant function, that was this one. The identity function, that was this one, are two special types of what other kind of function? What do we call this one? Okay, but it was called the linear function. The form is a slope-intercept form. The function is a linear function. Because you see the constant function here, the a is 0, so b and c, you could just name them either thing you want to, they're just constants. Over here, the b is 0 and the a is 1. So this would be also, these all form straight lines. This one has a y-intercept of b and a slope of a, so that may be going like this, it may be going like this, it may be doing any kind of a thing like this. It could be a very steep function, anything. This one is a constant function. It's always horizontal. Okay? It's like these, that they're straight lines, but it has zero slope. This one always has a slope of exactly 1 and has to go right through the origin. Always. Okay? So these are special cases of those. So the constant function and the identity function are two special types of linear functions. All right. That was your vocabulary. Your homework exercises, I've given you many of these before. Here they are. Either 11 or 13, both are at Calc Chat. 11's at Calc View. This is starting on page 65. Any of the odds 15 to 25. It says you may need a graphing utility for some of these, but I think you can probably figure them out. They're all at Calc Chat. 27 or 29, both at Calc Chat. 27's at Calc View. 31 or 33, they're both at Calc Chat. 31's at Calc View. Any of the odds 35 to 39, they're all at Calc Chat. 35's at Calc View. 41's at Calc Chat. Either 40, any of the odds 43 through 47, they should all be at Calc Chat. You got a true false at 49, that should be at Calc Chat, and that's it for 1.6. All right. Any questions on section 1.6? Yes. Okay.
I'm at work and I'm listening to you working at the same time. And I'm sure you are already said twice or 3 times already. But did you say our test is located under? Can you tell me that again? I missed that one.
Okay. I tried to put it under week 6, test 1, but whoever set up the template didn't allow me to put anything in there except the conditions. So I put it under, and I always put it here, under Blackboard message. Okay. Now, you may not have heard the complaints that were being had. I pulled up what I put out there, and it's a really neat looking, it says quiz 1, but it's going to be test 1. The problem is, though, that the Word version I'm using, some of you may not have, and Word has screwed it up so that some people can't print it properly. So what I'm going to do is this evening, because I'm in class from now until 5:45, which is 2 15-minute breaks and 1 30-minute lunch break, so I won't have time to do this until this evening. I'm going to post the test as a PDF file. I've got to go downstairs with my wife's iPad, take a picture of it with Adobe Scan, and put it. I'll also put that under Blackboard messages. So you'll have 2 test 1 there. One is a Word file, one is a PDF file. Hopefully all of you will be able to read the PDF. And I understand now what the problem that Dee was having last night when we were talking on the phone. I thought I had put it out there as a PDF, but it wasn't. It was a Word file, and that's where the problem is. Word screws up everything. So Microsoft, I really don't like their products, but they have a monopoly, so you have to use them. All right, now I'm going to, I got several things. First, I'm going to try to end this. Yes, I was able to do that. And okay. Now everything is in the way. Okay. I've got to scoot this over a little bit so I can close 1.6, and it didn't close. All right. Now 1.6 closed, I hope. Now I need to get 1.7 up, and I can't find my cursor. Okay, the cursor just disappeared. There it comes. Okay, came back. So let's go with a new share. Let me just check and make sure nobody else is waiting. They're not. So let's go to a new share. And there's 1.7. All right, good. Sometimes when I load them both, one of them won't show up. So here we have 1.7. All right, and let's go to current slide, if I can get that to open. And here we are. Chapter 1 is functions in the graph. We are now in, and by the way, Terrell, did that answer your question? Okay, maybe back at work. Okay, it did. Okay, great. All right, good deal. And if you can't open that one, hopefully this evening there'll be another one. All right, we're in chapter 1, functions in the graph. We're in starting 1.7, transformations of functions. And this is what we're talking about right at the end with the parent functions. Okay, our objectives here are to use vertical and horizontal shifts to sketch the graphs of functions. They love sketching graphs. We'll use reflections across the x-axis, across the y-axis, or across the origin. Reflections to sketch the graph of functions. And then we'll get to what they call non-rigid transformations. Both of these, if you're just shifting or whatever, the shape of the function stays the same. Even reflecting, it may flip it upside down, but the shape will be the same. But a non-rigid transformation is either going to be a stretch or a shrink. Could be vertical, could be horizontal on either of those. Okay? Those are the non-rigid transformations. We'll get to those in the last part of 1.7. Okay, so let's start with these shifting graphs. Okay, many functions have graphs that are transformations of those parent functions we did at the end of 1.6. For instance, look at this one. H of x is equal to x squared plus 2. There's that squaring function. And this is why I like to call it the squaring function, because h is also a quadratic function. So I didn't like them calling it a quadratic. It's the parent function for all quadratic functions, but this is the squaring function, but they've added 2 to it. So guess what that does to the graph? Here is the original squaring function, the parent function we had before, f of x equals x squared, in the light blue here. And what they did, they just took every point, 0, 0, went up to 0, 2. They took 1, 1 here and went up to 1, 3. They took negative 1, 1 here and went up to negative 1, 3. Every point was shifted upward 2 units. That's exactly what you did. You took the squaring function, moved it up 2. By shifting the graph of f of x equals x squared, that was your squaring function, the parent function, up 2 units, you get this new, and this is a quadratic function. The other is 2, but this is a more general quadratic function. Shifted up 2 from before. Now, there's a tendency to say these things are parallel. They don't look like they're parallel, so I don't like to use that terminology here. That's just a shift upward. These are never going to intersect because this is going to keep moving upward, just like that keeps moving upward. They'll get closer and closer together going that way, but always vertically, they'll be 2 units apart. Wherever you are on the graph, they'll be apart, 2 units apart vertically. So that's a vertical shift. Okay? In function notation, h and f are related this way. H of x is equal to x squared plus 2, but f of x, remember, was x squared, so that was f of x plus 2. So you take this function, move it up 2. Upward shift of 2 units. Now, not quite similarly, but sort of similarly, you can obtain the graph of g of x, which is x minus, oh, and by the way, time out. On a vertical shift, notice what you're adding or subtracting from. The y value. Remember, what is f of x? The main thing you've got to remember, f of x is equal to y. Remember that. So you've added to y. Down here, you are subtracting from x, not from y. So this is going to be horizontal because the x-axis is horizontal, the y-axis is vertical. So there's a thing to keep in mind. Now, I'm going to tell you this now and tell you this repeatedly several times. Anything you're dealing with x's seems like it's backward from what it would be for y. This is a x minus 2 here, so does that mean we shifted to the left? No, we shifted to the right 2, okay? And here's why. If you put a 2 in here for x, this becomes a 0. 0 squared is 0. So basically, you shifted to the right 2 units. So everything dealing with x is backwards. The minus sign shifts you to the right. The plus sign shifts you to the left. On the y's, a plus sign shifts you up. A minus sign shifts you down. So remember, when you're doing from the x, not from the y, from the x, then you sort of go backwards. Okay? So this is shifting the graph of f of x equal x squared. The same parent function here, but it's shifting it right 2 units as shown here. Okay? Even though that's a minus sign, you're moving it to the right. And not just 0, 0 moves to 2, 0. 1, 1 moves to 3, 1. Negative 1, 1 moves to 1, 1. 2, 4 up, well, you can't see it because they don't show it. Sorry, it keeps advancing the slide on me when I'm not wanting it to. Okay, any questions about horizontal shifts? Remember, when you're adding or subtracting from the x, always move in the opposite direction you would be tempted to, okay? Plus would move you to the left, or minus moves you to the right. Vertically, a plus moves you up, a minus moves you down. Okay. In this case, the functions g of x and f of x have the following relationship. G of x, which is x minus 2 squared, would be f of x minus 2. That's a right shift of 2 units. Right, because everything dealing with the x's are backwards. Okay. The following list summarizes this discussion about horizontal and vertical shifts. If c is a positive real number, the key is it's positive. It can be any number in the world. Pi thirds, square root of 2, 17, any positive real number. Okay. Vertical and horizontal shifts in the graph of y is equal to f of x are represented this way. A vertical shift c units up would be f of x plus c. There you have it. A vertical shift c units down, if c is positive, would be f of x is equal to, h of x is equal to f of x minus c. You drop 2 units. C units, all right. A horizontal shift, c units, to the right would be, I think someone just left the class. I don't think anyone's trying to get back. Whoops, went to the wrong one. Sorry. Yep, don't have anyone waiting. All right. A horizontal shift, c units to the right, will be f of, if it's horizontal, you're adding or subtracting from the x, not from the y. F of x is equal to y. So these vertical shifts are adding or subtracting from the f value, the y value. These are adding or subtracting from the x value. So these are going to be horizontal shifts. But the minus c moves you to the right. The plus c moves you to the left. X minus c, x plus c. Any questions on your shifting graphs? All right. That, I think, gets us to, it won't advance until I click on the slide. Oh, some graphs can be obtained. It looks like they're skipping. No, this is the bottom of page 67. Some graphs can be obtained from the combinations of vertical and horizontal shifts, and we're going to do that in 1B. Okay, vertical and horizontal shifts generate a family of functions, each with the same shape, but at a different location on the plane. That's what vertical and horizontal shifts do. So here it says use the graph, and I learned something new about my graphing pen by accident yesterday, and we'll see if we can use it today. So what I'm going to do is first graph this one. So let me put my y-axis here. That's supposed to be vertical. Don't laugh. Here's my x-axis here, axis here. That's supposed to be horizontal. Don't laugh. And f of x is equal to x cubed. 0 cubed is 0. I'll just tick off a few points here. I'm not going to need this many points by any means. Okay. 0, 0. When you plug in a 1 here, where is it? There it is. X equal 1, y is equal to 1. 1, 1. Plug in a -1, you get a -1. Okay? If you plugged in a 2, you get an 8, somewhere off scale here. Oh, here comes Ladarius. He must have gotten booted off or had to leave for a moment, so he's back in now. Let me make sure nobody else is waiting. Yep, got them all in. Okay. Now, so what happens here, and a -2 would give you a -8, which is way off scale here. So this comes up very steeply here, very steeply, and then when it gets close to 0, it flattens out. Remember, this is your cubing function, and then it goes up steep here. Eventually, we'll cross x equal 2, x equal 3, but it's way, way up there. And same with the minus. Now, there is the graph of f of x equal x cubed. Now, here's the part I found out yesterday by accident. Okay? Give me a color. What color would you like? We got black, sort of orange. You want black? Okay. We're going to do g of x in black. So what is that going to do? Okay, someone's microphone's on, I believe. Okay. What are we going to do? How is g of x? Down 1. You're absolutely right. So this one goes down 1. This one goes down 1. This one goes down 1. Okay? And then it does something like this. Goes through this one, goes up, and then goes right along next door to that one. There is perfect. There's g of x. Okay, give me a different color for h of x. And if y'all can't see my colors, I've got orange, yellow, green, light blue, middle blue, dark blue, and violet or lavender or something like that. Give me another color. Anybody? Green. Okay. Green, it's green, they say, on the far side of the hill. Okay, there we have it. So what will h of x look like? H of x is going to be in green. Uh-oh, what are we doing here? What does this do? You got it. Left 2 and up 1. So let's go from the origin. Go left 2 and up 1. Just don't say yours. Okay. Okay, there's that point. This one will go left 2 and up 1. It'll be right here. This one will go left 2 and up 1. It would be right here. We're still off scale with everything else. So these are going to come like this. Very steep coming up here. Then flattens out right here. And then bends and goes very steep up here. There is the h function. They all have the same shape. It's just they're located different parts of the graph. Does that make sense? And this was the one that's a combination of horizontal shift. If I could find this, where is my pen? Oh, there it is. Wait, no, there it is. Okay, it's a come on, where are you? Oh, there you are down there. Okay, here. It's a horizontal shift 2 units to the left, a vertical shift 1 unit up. Okay, so there is your horizontal and vertical shifts of a function. Any questions on that before we proceed? Let's see how they did it. Now here's the good news. I've been saying all along I can't erase on this slide. I found out yesterday I can. I can come down here and erase all the ink. There it went. Okay, so let's see how they do it. Relative to the graph of y is equal to f of x is equal to x cubed. Now they have theirs being a little bit flatter here than I did. Well, they blew up their scale some too, so have it a little bit flatter. The first one is just a shift downwards, so the flat part goes down, these parts go down, everything goes down 1, and there's your second one. They used dark there as well. So there's A, just like we did. The B part has a horizontal shift 2 units to the left and a vertical shift 1 unit up, and sure enough it goes left 2, up 1. Every point goes left 2, up 1. So now this shape here gets replicated up here, exactly the same shape but shifted from here, center there, to center there. There you have it. Now here's a little bit of a connection with something we did before. This function here we called an odd function because everything that's happening to the right, the opposite is happening to the left. It reflects across the origin. The only exponent you have is an odd exponent, so it's got to be an odd function. This one, however, is not. That's a neither function. Neither even nor odd. It's not reflecting across the y-axis. That would be even. It's not reflecting across the origin. That would be odd. It's a neither function. Well, yeah, of course. If you expanded this, you'd have cubic terms, you'd have square terms, you'd have linear terms, you'd have constant terms. Some of those are positive, some of them are negative. Some of them are even, some of them are odd. Hey, that's a neither function. Okay. So this one back here, that was a neither function because this is odd, that's even. So that's a neither function. The parent function is still odd. This one here, where was it? This one, okay. Oh no, I'm sorry. It was the earlier one that we were looking at, the x squared plus 1. That stayed even because it didn't mess up around the y-axis. Okay, so let's move on. Now we're going to deal with reflecting graphs. Okay, and by the way, after every example, there is a checkpoint. Now, y'all are going to help me keep track of time. My watch battery died. I don't have a watch on and I can't see the computer time. So y'all going to help me from going over because I got another class 15 minutes after this one. But please don't let me go too long. 42. We got 3 minutes. Okay. There's a checkpoint, bottom of page 68. Let's just quickly go over reflecting graphs. Okay. Another common type of transformation is a reflection. For instance, if you let the x-axis be a mirror, then the graph of h of x equal minus x squared. Here is x squared, f of x equal x squared. That's our parent function, the squaring function. When you put a minus in front of it, that negates the 0. It negates from negative 1, 1 to negative 1, negative 1. From positive 1, 1 to positive 1, negative 1. You're reflecting across the x-axis. You're negating the y values. Look at that. This is your y value, x squared. You're negating it. So every y that was up here flips down here. Every y up here flips down there. That is a reflecting. It's a mirror image or reflection of the graph f of x equal x squared. Okay. Now, how are we doing on time? 43. Okay. Didn't advance much, did it? Okay. These are reflections in the coordinate axes. Reflections in the coordinate axes of the graph y is equal f of x are represented as follows. Reflection in the x-axis, that means across the x-axis, that means you're negating the y. You're going from up to low, or lower to upper. That's reflection across the x-axis. Negate the y, which is minus f of x. But if you're negating across the y-axis, you're negating, if you're reflecting across the y-axis, you're negating the x's. So what was over here moves over there. That is a reflection across the y-axis. F of, instead of f of x, is f of minus x. All right. Now, do we have time for example 2? I'm guessing not. Do we?
No, sir.
Okay. So let me mark the page here, and we'll be picking up here. Oh, example 2, that's exactly where my mark was before. Homework exercises here, and we actually made pretty good progress there, would be any of the odds, 5 or 7. They're on page 72. And I think we have to stop there because the rest of them are stretching. Well, not all of them are stretching. You might be able to do 9A. You could do 9B, but then you'd have to stop. So just do 5 or 7. Okay, you got plenty to do in 1.6. Do 5 or 7 in 1.7. Any questions? Good deal. And good class today. We got started a little late with all the issues, but hopefully we got those resolved. Okay, or we'll have them resolved anyway. And I sure hope y'all get your checks, okay? They get those deposits made in a few business days. Okay, so I'm going to stop sharing now. I'm sick and tired of sharing. Any final thoughts, questions, issues, concerns? It is 9:46, but there will be no extra charge for that extra minute. Okay? Take care. We'll see you on Thursday. Okay? If I hear no questions, I'm going to end the meeting. Bye-bye.